So I think we're good to start. Hello and welcome everyone here for a second panel discussion at DKF 2025. Today's topic is leveraging AI in market data. My name is Stefan Wilhelm and I will be your moderator for the next 45 minutes. We're definitely living through what many call an AI revolution, right? A transformation that is not only changing the way we work, the way we think, make decisions, and build systems. So even my 15-year-old daughter is interacting with AI on a daily basis. So the change is not abstract and futuristic. It's already there, it's personal, and it is widespread. In this panel, we like to explore AI's impact from multiple perspectives. The market data vendor perspective, the consumer, academia, and software perspective. We want to understand not only the opportunities, but also the practical steps being taken and the concerns that may come with rapid adoption. I'm extremely happy to be joined by 5 human experts today and not AI agents debating each other. So that's probably something for upcoming DKFs. We'll start with a brief round of introductions and then we jump right into our discussion. Toward the end, we'll have around 10 minutes for question and answers from the audience. So please feel free to submit your questions via Slido. We'll display a QR code for the Slido app shortly. All right, so Ben, would you like to start the round of intros?
Yeah, so I'm Ben Humphreys. I'm head of data engineering at Parameta.
And I'm Christophe Plouvier. I'm product manager for Exmon, which is a cost and usage monitoring solutions for reference data at TRG. And I'm also AI lead, so coordinating the AI initiatives for TRG.
My name is Andrey Popov. I'm vice president at JP Morgan, working for the team called Pricing Direct. We are pricing like several millions of securities on a daily basis.
And my name is Reinhard Heckel. I'm a professor for machine learning here at the Technical University of Munich.
My name is Jochen Papenbrock. I work at the AI platform company NVIDIA, and I'm heading financial services for Europe.
Okay. Thank you very much. You see very, very different angles. Let's kick things off by getting a quick pulse from you in the room. So please raise your hands if you already moved beyond proof of concept with AI and are actively using AI in production. Can you raise your hands who's using AI in production already? As you can see, quite a few. So, this gives us a good starting point for our first topic. Where do we stand today in using AI? I'd like to go around the panel and ask you 2 questions. First, where do you see your organization in using AI today or adopting AI? And the second, where do you see the drivers or possibly also the blockers that you're seeing for scaling AI beyond pilots? And Andrey, I would like to start this round with you, simply because JP Morgan was recently highlighted as one of the AI leaders in the 2024 AI Evident Index. So, would you share your perspective?
Sure. So I would probably, looking back like 6 years ago, we actually sitting pretty close with like AI machine learning teams. And back in the days, it was just a kind of several PhD students kind of talking about the models and how to apply them to the financial data. And it was relatively small. But the speed at which kind of the department was building, the teams were kind of created across the regions, especially in the United States and San Francisco. So at some point, you started having a call with the university professors who explaining the certain benefits of applying a model to a particular financial data set. And then you're thinking, wow, that might be really interesting. And then several years later, you started to have AI or machine learning models pretty much for a lot of things, for a seating arrangement in the bank, for generating some financial data, for categorizing it, for trying to make a time series prediction. And the scale and and the size and the number of different models is growing exponentially. So, and the departments is really big, by the way, for AI and machine learning teams. So over the past 5 years, yeah, we've achieved quite significant progress where people are interacting with AI across the teams on a daily basis, whether you are in trading, in research, in quantitative research, the AI agents which are helping you to create a code, they've been like a time savings for us. So yeah, we are not yet at the stage where everybody is using AI like a 15-year-old daughter, but we are getting there in the financial markets.
Mm-hmm. Do you see any specific blockers on your way?
So I would say the regulatory requirements, they are a blocker, and we can talk about it a bit more in like the model approval process, because a lot of regulators, they want to understand what's driving AI models, how do they perform, where do they fail, and that is a kind of, not an obstacle, but I would say a challenge, and rightfully so, because you need to ensure, and everybody needs to ensure that the models are working correctly. And then sometimes the applicability of a certain model is a bit of an issue, where you want, like, there are some really great models, but people are yet to figure out how to apply them to the financial data sets. One of the recent interesting examples is that, for instance, the generative adversarial networks are getting quite popular among banks and the hedge funds, because people realize that they could be quite precise with predicting, for instance, your volatility surface. And suddenly there is a spike of interest in these models. Now, there are many other models, but the banks are yet kind of to find out how to apply them.
Okay. Ben?
I would say that the key requirement for adoption of this stuff within the org is to actually just make the tools available to people. So we've built within the org, we've got a sort of a evangelist team that is pushing these tools out to our organization. We are using LLMs within our engineering teams, and our experience has been that they are now, the agentic AI is now about as good as an entry-level engineer. So they are picking up relatively small tickets, but writing code, and we've managed to actually have entirely AI-generated commits into production code, and it's out in the wild being used. Obviously, there's a human in the loop, so everything is checked. And it really is just about making the tools available to the people in the organization, and people are very excited about the tools in general and just using them.
All right. Any? Reinhard, do you have any views from academia?
From academia? Well, like, my impression is that there's still a lot to do in terms of adoption, right? Like, so the things that we can do and the models that we have and so on, it seems there's still a lot to do in terms of adoption. And also, like from speaking to some of you yesterday night, it seems like that a big problem is often the data is not available for training and for processing and so on. So there seems to be like a lot of issues, not necessarily from the technical side, but also just from regulation or from contracts.
Mm-hmm. Yeah, that's definitely true. So thank you very much for this, these insights into your AI strategies so far. And it's clear that adoption is growing and accelerating. And so, but now let's zoom a little bit into real-world use cases. So what is actually working in your organization? So what use cases are you currently working on, and what role are AI agents play in this context and AI automation? Christophe, perhaps you can kick us off here?
Sure, absolutely. So I think at TRG, so we're using AI already for about over a year on the code generations helper. And again, it increased, let's say, a size of delivery of code of over 10%. But also, I think here what is important is to look at what we can deliver as part of a product suite. And here, this is really important to define the right use case. So at TRG screen, we've got two main use cases that drives a business, which is inventory and usage monitoring management of reference data. So the first one is document digitalizations, where actually we can use then the AI to help us to retrieve out of all the thousands of invoices that clients receive every month, collect every relevant piece of information, and use that to implement and upload it into inventory management systems. So basically, you use the AI to really do the automations that before, because of the unstructured data of invoices, this had to be done by a human. So it brings a lot of efficiency, of course, and a very good, let's say, time to market for these products. And the second type of initiatives we're looking at is the AI Assist, which is basically bringing the AI chatbot within a product. So within a product means like it needs to be contextual to the client data specifically for his questions. And here we're actually using the, let's say, AI agentic approach, where we have at the front end an orchestrator to understand the intent of the user. And then once we understand which actual agent to call, which piece of particular piece of data, we can then do a second call to the pre-trained LLM and enrich that with the context of the client, specifically with the data that is relevant to his questions.
Right. Jochen, you talked about agentic AI a lot in your keynote this morning. Like, how do you see it from your perspective?
Yeah, it's a great value driver, I believe, because those models will become even smarter, doing more autonomous things. So you can have specific agents for certain tasks like web search, calculation, collecting data sources, and then you have an agent that would orchestrate the other agents and also maybe interact with human employees, so that digital and human employees could collaborate, but also agent-to-agent communication, obviously. Maybe even cross-vendor, that every vendor has an agent and they could interact. And in our own company, we are heavily using agentic AI. I mean, we started using AI internally 2012, actually, because that was our sort of starting point in AI, where we developed software for training deep neural networks, which could be accelerated with GPUs. And later on, the models became a little bit bigger. Like, we helped OpenAI build their ChatGPT then with tens of thousands of GPUs, right? And so we could actually accelerate our internal product lifecycle by up to like a speed of 1 year. So before that was 2 or 3 years since we came out with a new chip. Now it's 1 year, because we use AI internally both for the hardware optimization. So it could be an optimization problem, which is maybe similar to optimizing a portfolio, for example, but also for making knowledge accessible to others inside the company. We obviously have some chip design IP, which should stay in our company, but engineers need to access this. So we built an internal sort of large language model that would access those chip designs, so the engineers could chat with this very useful data, and we activated this data set for all the engineers in the company. Nemo, chip Nemo, we call that. Yeah, and today we try to use AI wherever possible, either external tools like Perplexity or internal tools that we even connect with external tools, so that you could also process confidential information and not sharing your data and what you are investigating with external model providers. Yeah, so it's just the beginning, actually, and making use in AI like marketing, sales, engineering. Basically, I can't imagine any area where we don't use AI these days.
Yeah, you mentioned it, that you're using internal data. So my question also to the others would, how far have you come in using AI for internal or proprietary data sets? Are we still mostly working with public data or synthetic data? Where do we see
I think here at TRG the same way. I think we build, let's say, a lot of internal agent that is basically enriched with, let's say, our own, let's say, proprietary data, like, for example, the sales enablement. So we've got a tools that contains all the FAQ of the typical things that we, that the sales use, that marketing provide, let's say, all the materials. And this is then plugged to a pre-trained LLM model. And then in terms of adoption, actually, to make the link, to make it very user-friendly and the users to use it, is actually we put it where the user is. So all the a lot of discussions in terms of deals and transactions is happening in an internal Slack. So we created that enriched contextual LLM in a channel of Slack that you can actually invite in your current discussion that you have with your colleagues. So it makes it available for you, and then you can then, in a case, have your colleagues that checks all these informations that would be, required search, etc., or knowing the right person within the organizations.
Are there any key lessons from these use cases that you would like to share here? So anything specifically?
So I think for us, one of the things we're most excited about is we've got 20 plus years of history. And 20 years ago, no one was thinking about really how the data would be used now. So there's lots and lots of information buried in ticketing systems and email archives, right? So by using an LLM, you can very quickly gather all that information and create a data store that you can then make available to your internal stakeholders and your clients. So that's something that we're really excited about and working on actively at the moment. So I think that's the next big one internally for us.
When you're using AI internally, do you have any measures of success for these kind of initiatives? Like, how do you measure the success? Is it return on investment? Is it speed? Is it adoption, or something else?
I think productivity is a big one. I think productivity is probably the biggest, easiest gain for most organizations, because you can use your own internal systems. You haven't got to worry about making things available to the external world. And it's the best place to start for most people.
All right. Thank you very much. Now let's shift to the models themselves. How we choose them, how we build them, how we get them approved. From my perspective, large language models clearly dominate the headlines today. But let's start with the foundational question. Does classical machine learning still have its place? Or put it differently, when it comes to selecting a model, when do you choose an LLM and when do you opt for a classical or custom machine learning pipeline? Jochen, would you mind opening this round?
Sure. I mean, we have customers in banking, and for them, AI model risk management is crucial. And whenever you have, let's say, two models that can do the same thing and one model is smaller and less complex, you obviously choose that one. Right, and it's machine learning, traditional machine learning AI is not going away. Rather, it will be connected to the Gen AI layer, which allows us to access models and data with our human language and make it more accessible to a broader audience. Right, so in the end, it will be a mixture of data sources, predictive models, Gen AI, and then there's the agentic AI layer that does some autonomous task, and you have also layers where you need human interaction, right? Where you use human language that interact with data in real time. So all these combinations exist, and what we need to take care of, obviously, is AI governance, and we have provided some open source tools where we work with our customers that help you validate your AI model, so you can sort of evaluate what is the quality of a certain model. For example, there's a new Mistral or a new Llama model or something is coming out, and you want to test the quality of the system, and maybe also do some fine-tuning of your model, and then see if that fine-tuning exercise actually improved that model or destroyed the weights altogether. Both things can happen, right? So you need to be able to quickly check the quality of your model, which could be academic benchmarks, but also, let's say, a database of internal metrics that allow you to estimate, is this a good model or not, right? Another technology I think that's important to use, and we saw this in one of the NVIDIA GTC open public talks by UBS Bank, they used a technology called LLM as a judge. So you use AI to validate your original AI model. Why do it manually when you can also have support of an AI, right? So that AI will stress the original AI as much as it can and see where it breaks. Yeah? Every model risk manager loves that exercise. And also, there are some interesting open source projects that we are engaged in. For example, there's one called Nemo Guardrails. So the problem with guardrailing is that you can formulate some policies around your model, like some guardrails, as the name says, but this makes your model really slow in runtime, in production, right? So, so that project, Nemo Guardrails, is about still optimizing the latency and at the same time checking for complex policies while you are using that model. For example, to filter out intrusion from outside, like cyber attack, or somebody want to steal your data, but also if somebody want to misuse the model for a dialogue that's inappropriate, right? For example, using a model to extract financial advice where there shouldn't be advice, right? And then getting sued is not such a nice thing. So guardrailing is important. And when you then also build these RAG pipelines where you connect your model to your own data, that's another way to reduce the hallucination, and you make this model more auditable, because you can sort of drill down and see why was a certain document selected, on which basis, and then you can read if that's really appropriate. So all these tools, let's say, working in parallel, this will make, to a certain extent, your model more trustworthy, responsible, but nevertheless, this is technology, so you need to obviously have an AI governance framework around it, processes, people, experts that have the last word, let's say, or check the model before it goes out into the public. Yeah.
All right. Yes, that's a very good point. So it brings me to the organizational side of things. How do we get models reviewed and approved in your organization? And what kind of hurdles are you facing, or what kind of requirements and audit checkpoints are you facing? Andrey, maybe you can just share your perspective, because you've dealt with this firsthand.
Yes, it's quite a lengthy and honestly sometimes painful process to go through the whole model approval, validation, review, then like an additional testing, like you testing it as kind of a stress testing the model and seeing its performance, and then enhancing the model and going back. And sometimes you wish you would be kind of in a startup where the guys can literally deploy the models very quickly, whereas in the bank you go through this whole process and there is a significant audit trail to be kept in and reviewed. And I think there has been a bit of a lack of the standards on evaluating certain AI models, but from what I see, the things like Shapley values getting more and more common, and certain matrix, which is kind of reviewing the model performance, model failures, they becoming more and more standard. So at some point, I think we'll have a proper sort of model audit process, which will be industry-wide implemented. Maybe we are not there yet, but we are coming to that point. But at the moment, the process is lengthy. And once you finally get in your model approved and kind of loaded in production, that's a very happy moment.
Right. Any other perspective on this?
I mean, at the TRG, for actually the applications that we, let's say, deliver as a feature to our clients, like the AI assist, etc., I think it's very useful for them, because it gives them like that customization of dashboard. You know, when you create a software, you always have, okay, the user will want to see these analytics with these slice and dicing, etc., and you deliver that, and then every client will say, oh, but what if I want to do this, and what if I want to do that? So there's always that flexibility that is always difficult to reach to satisfy all the clients. So I think here the AI assist is a wonderful tool to custom that view. But so that's, and on our side, because actually we need to, for each instance, we need to, in a way, we use just predefined LLM model. We do not work through model iterations and creating our own models. What we have is pre-trained general LLM model, but we enrich it for the particular sessions of the clients with the client data. And that is very important to actually, in a way, work like this. We initially started with some machine learning, but this would not go, let's say, ahead with, let's say, the client's requirements, where most of the client will say, no, don't use my data to train models that after the other, the other clients, the other institutions will see the derived product of my data. So I think that's why, from an application point of view, the way we've run it is really using the pre-trained LLM and contextualize with client data for a given session.
Okay. Coming to specific model, like we all have seen the rise of DeepSeek out of China, and just made the headlines. So my question would be, how do their architecture and training approaches differ from Western models like OpenAI or Anthropic? Reinhard, what is your view?
Yeah, so my take on this is, like, it's very similar, what everyone does, and so DeepSeek is a really good company. They have a very competent team, and they build a really good model. And what happened in the last 2 years, like since GPT-4 came out, is that the models really, like the way we build models really became better. So there are a lot of improvements on all sides. So for example, a lot of improvements on how we curate data. And so that makes, like, if you have better data, you need less training, so that makes it more efficient. And then there's also a lot of small improvements in the model, making it more efficient and so on, how to run it on a GPU. And DeepSeek was using all these things and also, adding some on their own to build a really good model, the V3 model. And I think what's really interesting about this whole DeepSeek stuff is that now, if you want to learn how to build a really good model like GPT-4 or so, you would read a Chinese paper and not an American paper, right? And that really changed. Like in academia, you would now you learn more from those papers because they disclose a bit more about how they do things than, for example, like Meta does or other American open source models. I think that's interesting.
So your point is that they're not doing the training with less resources, would just have different data.
Yeah, I don't think they do it with less resources. So they spend, on their training run, they spend 6 million, right? But if you look at how big is their team that created this model, it's a similar sized team that created GPT-4. So they have a paper, there's a GPT-4 paper, and to build such a model, you need a data team, you need a model team, you need, so you need a bunch of teams. And the size of the team is very similar than the team that OpenAI had to build GPT-4. And you have to pay these people, and you have to pay the experiments and so on. And so the total cost to create such a good model or such good models, they have a few models, is still really high. It's still super impressive what they did, but it's, so I think they're a really good team, but it's not that they have a completely different approach also than other people. There are some optimizations they did, especially with respect to GPUs. There's some links between the GPUs that they didn't have in a way, so they had to do some smart things to get around that, to utilize the GPU as well. So they did some smart stuff given the constraints that they had.
Okay, thank you, Reinhard. That is really an important perspective because while architectures certainly matter, as you outlined, it's not the architecture that makes a difference, but we all know that the real power and also the biggest risk often lies in the data the models are trained on. So let's shift gears to examine a little bit on data quality. How do you, as a professor, define high quality data? And do we still have enough good and clean and high quality data for the models to learn from?
I think there is still a lot of, so first of all, how do we define good data? I think it's difficult. So it's not that you can look at the data and say it's good. It's actually very difficult for a human to say this is good training data or bad training data. So good training data is if you train your model on that data, you get a good model. So that's the definition of good training data, and it's hard, right? Because you kind of have to then train the model to see if it's good, but that's what matters. And there's a lot has been happening on how we curate the training data. So there's a lot of effort on, so we start from a lot of data, we very heavily filter it, and then we curate it. Sometimes we change it a little bit, sometimes we even have artificially generated data. And there's a lot going on in that area and a lot of improvements. And if you kind of look at the models that we have out there, like GPT-4 or DeepSeek and all these open source models, the model they use, so the transformer architecture is extremely similar. There's like very, very minor differences. And the biggest differences in all those models are on what data exactly have they been trained on and for how long do they have been trained on that data.
Good, thank you. Any other perspective on the data side?
I think in market data, it's about having AI-ready data sets, and different use cases sometimes want more dirty data than others. And AI gives us an opportunity to actually help cleanse our data sets and produce different data sets for different use cases. So you can filter out all the noise, or you can leave the noise in because there may be some information in that noise. And I think as a vendor, that's where we are focusing a lot of our attention on actually using the AI to create data that is then going to be useful to people who want to train models on that.
And how do you, in your organization, make sure that there are no risks in the model, like biased models or model drifting and so on? And who in your organization is finally responsible if AI produces wrong signals? Is that institutionalized already?
I think it's important that every model and every data set has an owner. And ultimately, that person then is responsible. So we've got various streams of data, and everyone has an owner. And then how we use it, the person using it, owns the output of that. And that's how we distribute the responsibility.
To add a bit on the data quality, if indeed within your company or organization you have a dedicated data team who is kind of looking and curating, producing high quality data, you're pretty much sitting on a gold mine, because to do all this work and maintain the appropriate data set which is ready to be trained on certain models which will produce meaningful results is crucial. And in some areas, for instance, there's been a bit mentioning of synthetic data. There are some areas of the financial market data which is relatively underrepresented. For instance, it's probably to the better. You don't have a large data set of high yield or near default companies, which means that you don't have a sufficient data set to build a model which would predict when the company is facing bankruptcy situation. And then there might be a case where a synthetic data team can produce this additional data for researchers to be able to train the model and then build an application based on that. But yeah, there are quite a few challenges, and usually within the organizations, it could be the business team which is ultimately responsible for the results they're getting. But if the model is produced by a dedicated machine learning team, they would be looking first and foremost on the quality of input data, and they would be asking the business side to provide a more meaningful data with the better quality.
Okay.
So maybe one thing, so at the very beginning, we also talked a little bit about how people use these AI models, right? Like in companies, and you mentioned, for example, that people use it to, have a pre-trained model, and then they have some RAG system, and then they use this internal data like this. And I think that's also interesting. A lot of people right now use the data more, like internal data, more like as a reference and so on, so they don't change the model. But there's like a lot of applications where you can have your model, like an open source model, and then you fine-tune it based on company data, and then you really get better at some specialized task. And I think there's a lot of value in doing that for specialized applications, and this is something that people don't do as much in practice yet. I think they take the models, they use them, but there's a lot of value in specializing them for all sorts of situations based on the custom data.
On the data quality side and model quality side, I think it's a function of hard engineering work and compute power. because, for example, when you curate your data sets to use them for the customization step, that's already quite compute intense, so you need to make sure that you have an efficient compute platform there to create the data sets. And you do all these fine-tunings, right, which are more or less intense, right, depending on what you want to build. So here also is important to have an engineering team that's really capable of doing these things, and the platform that allows you to frequently retrain these models and fine-tune and then evaluate the quality, because evaluating quality is just a lot of computing a lot of metrics that you have defined before. And when you build these RAG pipelines, that's where you sort of use the foundational models, open source models, for example, to tap into your own very valuable and unique data sets. That's also something where a lot of potential is there to build good RAG pipelines with high quality output. And that's, again, a function of how hard the engineers work and how good, and also how well you use accelerated computing. For example, how good do you do your embedding and your re-ranking? How do you combine these things? And that's also a function of the compute power you have available, right? And on top, you would then put, as I mentioned before, guardrail model and all these things. And coming to these reasoning models, I think that was a very interesting time when this DeepSeek came out. Like at NVIDIA, our engineers looked at how they built this, and we came up with an own sort of version of this, which is better and smaller in the end. Smaller means less inference power needed, right? So I think it will inspire the entire open source community to build more of these kind of reasoning models, and that's reasoning models are the basis for more intelligent agents, yeah. Because they can do more complex tasks autonomously and also improve the quality, obviously, of those models. So, and another factor of data and model quality and privacy is also the decision, do I use an API-based model, a ChatGPT, a Gemini, which is the easiest way to get started and very powerful way, obviously. Those models are really huge. Maybe sometimes you need specific jobs and you don't need the huge model. You can have a much more energy efficient and cheaper model to run certain tasks. And maybe you have very confidential data that you want to tap into and you don't want to share with the model provider, because don't forget the ChatGPT Gemini is always a model that doesn't belong to your organization. It belongs someone else, right? So when you have very secret data sets and very unique data sets, you make sure that you have a foundational model in place, and ideally not even run this in cloud, but on premises or in a regional data center, right?
Thank you very much for your thoughtful insights in all of the question rounds. We'll now turn over to you, the audience, and we have reserved some minutes for question and answers from your side. So please submit your questions via Slido if you haven't done already. And there are already a number of questions coming in. To Christophe, what is your experience in using of AI Doc to fill the data fields of your market data inventory system?
So that's an interesting one, because let's say from the reference data point perspective, let's say a solution like Xmon will monitor your usage and the costs associated to your usage, but do not look at your data. So you do not look into the data point that you retrieve from the vendor, because we're not, let's say a golden source layer of your market data. So we do not look into the data field of the vendor. So as a consequence, we do not, let's say, have the capabilities to, let's say, complete data fields from there for the client, for example.
Okay. There was a question for, do you think AI will enable access to new forms of data that were previously hard to analyze, for example, open-ended survey responses? Do you think AI will enable access to new forms of data that were previously hard to analyze, for example, open-ended survey responses?
Yeah, I would say the document digitalization work that we are performing is exactly this, where you have, let's say, some unstructured data with some opinions and views, etc. So of course there's no opinion in invoices, but there's a lot of piece of data. We also extended that data documentations to document digitalization to vendor contracts in order to read the contents of this. So I think definitely for, let's say, a survey, for example, with open questions, I mean, the Gen AI is perfect to actually summarize, and actually not only summarize one given answer, is looking at the overall look of the response. Let's say you have 200, 300 response to your survey. It will actually be able to digest all of it and then bring a little bit of that consistency. And I think the Gen AI is actually perfect for this kind of summarizing of unstructured data.
Okay. I'd say that OTC data is very unstructured generally. You've got lots of phone conversations, lots of Bloomberg chats, lots of emails, and there's a lot of very valuable data in there there's very useful to people, and you can get market signals from it. So yes, I'd say LLMs are very, very good at things like that. So if you can use that to be part of your conversations, you can extract a lot of information.
Thank you. Next question. Do you have any ideas for using AI in market data operations?
I can answer that. So if you can power, again, large language model with a more dedicated machine learning models focusing on a specific area within the kind of the broader operations department, whether it could be something as simple as a kind of running a set of reports and then generating some data on the back of it. And then if it's all can be called within the large language model, I think that's called a function calling within the model itself. Then you can significantly streamline the whole operations reporting process. And again, it's probably the main focus here would be to boost productivity of the people, of the teams who are responsible for certain deliveries.
Okay. I think we can take two more. For Professor Heckel, what are the critical data elements, attributes that you and your team need to see in order to determine whether data is model ready?
Yes, it's an interesting question. I think, let's say a company has a particular problem that they want to solve, with an AI. Then the first question is, can this problem be really well defined, and can you measure success well? So, for example, let's say you have some sort of ticketing problem where you want to classify tickets or something like that, and then the most useful thing is when you can have some way of measuring success. So, for example, when you have some data that already humans labeled, and you can really say this is how a human would perform on this, and this is what we want. If you can define this well, then if you have a good team and good engineering team, you can already kind of start with this, so you can optimize for this, and then you can see what kind of data would you even need, and do you even need some data. And a lot of the data you could even use public sources, or you could generate that data, right? A lot of the reasoning models, for example, as he mentioned, are very exciting, and the data to build the reasoning models is largely generated from AI models to get them so good at reasoning. So I think there's a lot that one can do, just to generate the data or to leverage existing data, but the difficulty is more often than not to really precisely define the problem and have a way to measure success, whether the AI model would do well or not. Yeah.
Okay, thank you. And we'll take the last question. How to manage customers' expectations? How to communicate the weakness of AI and praise the result at the same time? Yeah, that's a very good question. Anyone willing?
I mean, we were leading by example, so obviously we have banking customers that show on conferences and somewhere else how they use these models, how they face or challenge, solve these problems when they have risk and governance frameworks, how to leverage AI to make it more trustworthy, and explain basically how they did. So leading banks, leading financial service companies, and that's important to look at Evident AI Index, and obviously have one representative here, so we can learn a lot from those leaders. And praise is important because Europe is lagging way behind. compared to US, so we need to accelerate a little bit on the AI maturity levels, but I see some good signals here recently. And yeah, the weaknesses, again, that's a function of good engineering work, good work with the data, and also access to compute. And then it's not magic to make these models better and ready for production. It's just very hard work and knowledge. Yeah.
Thank you very, very much for this very vivid discussion here on the stage. And let's catch up on the AI discussions while having drinks then later.
Thank you.
Thank you very much.
Stefan.